Continuing our exam 2 solution. So let's see question 6. Question 6, 8 points. So 150 people, so 150 in the sample space. 150 people were surveyed and asked if they believed in UFOs, ghosts, Bigfoot. So 3 categories. UFOs, let's call this set, we use a Venn diagram. So let's call this set UFOs. Right, let's call this set ghosts. So this circle represents UFOs. This circle represents ghosts and Bigfoot. So let's use this circle of Bigfoot. Right, this is a Venn diagram. Okay, so we're given these statistics. And the question is to ask, how many people surveyed believed in at least 2 of these things? Right, so if we remember, that's to look for this, the unit of these 3 intersections, because those people believe in at least 2 things. They either believe in 2 or 3, right? The middle part is 3. So we want to fill those 1, 2, 3, 4 spots. So in class, when we do review, we filled everywhere, right? We put the right numbers in every place. So that is for review. So maybe because the question could be asked in any way. So once we fill in the right numbers in the right places, we're able to answer all the questions. But for exam, we want to focus. We don't want to waste any time. We figure out this is asking how many people surveyed believing at least 2 of these things. That means the unit of those 3 intersections, right? Basically, intersection of UFO with ghosts, intersection of Bigfoot with UFO, intersection of ghosts with Bigfoot, then union them. So which is these 4 spots? One, you call this 1, 2, 3, 4. So these are 4 spots. We want to put the right numbers in there. Okay, so now let's do that. We're given 2 people believe in all 3. So 2 people believe in all 3, right? Because these 2 you see in everyone, in UFO, in ghosts, in Bigfoot. So we put the number 2 here. Now this is 8 believe in ghosts and Bigfoot. So the intersection of ghosts and Bigfoot total 8. But we already have 2 here. So 8 minus 2, 6. So we should put number 6 here. Then 10 believed in UFOs and ghosts. So 10 believed in UFOs and ghosts. That's this part. So total should be 10, but we already have 2 there. So 10 minus 2, this spot should be 8. Then 5 believed in UFOs and Bigfoot. So that should be this spot. 5 believed in UFOs and Bigfoot, because 2 is already there. 2 believe in 3 things. So 5 minus 2, which is 3. So 3 should be here. So the union of those intersections, just add those 4 numbers. So 8 plus 2, which is 10, plus 3, then plus 6, 19. Right, to answer this question, we just see 19 people surveyed believed in at least 2 of these things. So I know some of you, a lot of you just, fill in the numbers for everywhere. That's good too. But in the end, this is what we're looking for. Okay, that's question 6. Let's see, 7 worth 5 points. So customer account numbers for a certain company consists of 4 letters. Always underline the important information, followed by 2 single-digit numbers. So we can just draw 6 lines, right? 1, 2, 3, 4. These 4 letters, then followed by 2 digits. So we know we have 26 letters to choose from. We have 10 digits, 0 to 9, 26 letters from A to Z to choose from. So the question is asking how many different account numbers are possible if repetition of letters and digits are allowed. Repetition and digits are allowed. So let's see. So from the first letter, we have 26 choices, right? We can choose A, we can choose B, C, D until X, Y, Z, right? Any of those. Because repetition is allowed, so we can pick any letter for the second one too. For third one too, fourth one too, 4 letters. Each one we can choose from 26 letters. So we multiply them. For the digits, we have 10 digits to use from 0 to 9. Because repetition allowed, we have 10 choices for this spot, we have 10 choices for this spot. Then we just multiply them. By counting principle, right? Each category have this many choices. In total, we multiply how many choices we have. So now we have 26 raised by 4. So let's use our calculator. 26 raised by 4. So that's 4, 5, 6, 9, 7, 6. Then we have 10 times 10, which is 100. So we put 2 zeros here. So do second time, 26 raised by 4. Yes, still the same number. All right, so we need to do one more time to double check. Then we say, okay, 3, 3. So there's 697,600. That's how many possible ways to form this customer account number. Okay, now let's say 8. A, 5 points. So the president of the college asked a fraternity to submit a list of 6 students to serve as guides at a school function. They have 11 students who are available to choose from, to help to choose from. In how many ways can the students be chosen? So we could use permutation, out of 11, permute 6, or we could choose combination, out of 11, choose 6. So which one? So that's why the hint is here. Does the order matter? It doesn't matter because out of the 6 students, we're not picking president or vice president. They don't have titles. Everyone has the same rank. They're all guides. So that's not permutation. Permutation means order matters. Each one has different titles. So not going to use permutation. That's combination. Because the 6 members in being chosen are equally weighted. They have an equal rank. They're all as guides. So that's combination. Right? So out of 11, choose 6. So we just use the formula. The formula is given. We just substitute into it. So 11 factorial divided by 11 minus 6, which is 5 factorial, then divided by 6 factorial. Let me write on the side. So first, it's not permutation, it's a combination. It's a combination. So out of 11, choose 6. So that's 11 factorial divided by 11 minus 6, which is 5 factorial, then 6 factorial. So we want to rewrite 11 factorial as 11 times 10 times 9 times 8 times 7 until 6 factorial. Then 5 factorial, we want to write as 5 times 4 times 3 times 2. We don't really have to write times 1 because times 1 doesn't multiply by 1 doesn't do anything. Then multiply by 6 factorial. Well, 6 factorial divides itself, it becomes 1. 6 factorial divided by 6 factorial becomes 1. We call this cancellation. Now we can also cancel some of them. So we have 10 in the numerator, or 5 times 2 in the denominator. 10 divided by 5 times 2, right? 5 times 2 is 10. 10 divided by 10 is 1. So this canceled. Then we say 4, we can cancel with 8, right? 2, because 8 divided by 4 is 2. Then we have 9 divided by 3, that's 3. So what's left? I have 11 multiplied by 3, multiplied by 3, multiplied by 7, right? And the denominator just 1. Denominator just 1. Then we just use our calculator to do, well, 11 times 63, right? Because 3 times 3 is 9, 9 times 7, 63. Or you can just go one by one. 11 times 3 with 33, times 3 with 99, so on and so forth. All right, I double check. So I put in my calculator twice, double check my answer. So second time, I still get 693. So that's for 8. So how many ways to choose 6 students out of 11 students? There's 639 ways to choose that. Okay, now let's see 9. 9 is a little bit tricky. But we did have one similar question on the review. Let's see, Jace was born on November 11, 2002. So how many 8-digit codes could Jace make using the digits in her birthday? So we need to find the digits in her birthday. How many digits in her birthday? That will be our sample space. 0 is there, 1 is there, and 2. That's it. Only 3 digits, right? 0, 1, 2. So her birthday was made by 3 digits, 0, 1, and 2. So now we want to make an 8-digit code. So 1, 2, 3, 4, 5, 6, 7, 8. Well, out of the first one, so let's say the first spot, how many choices do I have? I have 3. Second one, this doesn't say, okay, this doesn't say repetition allowed or not. So if you want, you can do 2 ways. Otherwise, you do either way, I'll treat it as right. So one way, let's say repetition does not allow. Okay, doesn't allow repetition. That means that for the first one, we have 3 choices. And for the second one, we have 2 choices. For the third one, we have 1 choices. And for the rest, we have no choices anymore. So we only multiply these 3 numbers. What do we get? We get 6. So if we do not allow repetition, there are only 6 possible A number codes we can make. Right? And the rest is what? The rest is nothing. So most likely the repetition has to be allowed. So what do we do then? So the first one, we have 3 choices. We can put 0, 1, 2, either one of them here. Second one, same thing. Right? We have 8 spots. We multiply all those 8 threes. So that's a 3 raised by 8. 3 raised by 8. Well, 3 raised by 8 is 9 raised by 4, right? 3 raised by 8 is 9 raised by 4, because 8 can be split as 2 times 4. 3 raised by 2 squared, which is 9 raised by 4. Well, 9 squared is 81, so 81 squared. Or you can just hit into a calculator 8 times of 3. 3 times 3, 8 times, all right? But for me, I'm going to only do 81 squared. 81 times 81, which is 6,000, which is 6,561 of them. All right, so that's 9. Now let's see 10. 10 was 6 points, saying a jar contains 13 red marble and 12 blue marbles. If you reach in and pull out 3 marbles at random, what is the probability that all 3 are blue? All 3 are blue. Okay. So let's figure out. So we have, because 3 marbles, right? We have 3 probabilities. So what is the probability getting the first marble to be blue? How many blues do I have? 12 blue. So I have 12 blue out of how many in total? 12 plus 13, 25 of them. Right? So the probability of the first one to be blue is 13 out of 25. Then the second one, let me just erase this so that it's clear. So for the first marble to be blue, we have 12 out of 25. Now, since the one marble is out, we only have 24 marbles left, right? So out of 24, how many blues we have there? 11. So 12 minus 1, 11. Then the next blue will be 10 out of 23. So that's the probability of getting all 3 to be blue. We just multiply. Right? Just multiply the numerator with the numerator. So we get 12 times 11, that's 132. Then add 2 zeros, add 1 zero to it, so we have 1. Oh, maybe we can simplify first. Let's simplify. Because in the end, we have to simplify if we want to simplify, right? So we have, let me change my right color. I have 12 in the numerator, I have 24 in the denominator. 12 over 24 becomes half. So this becomes 2, 24 becomes 2, 12 becomes 1. That's the only thing I can simplify, right? Nothing else I can simplify. 23 is a prime number. 25 has a 5 in it. Oh, I can simplify this. I can simplify 25 and 10. 10 divided by 5, I have 2. 25 divided by 5, I have 5. So now the numerator, I have 11 times 2, which is 22. Then divide by 5 times 2, which is 10. 10 times 23 is 230. All right. If this is troublesome for you to see it, what you can do is you calculate the numerator, right? You get a 1,032, right? Then divided by the denominator. Denominator, you do 25 times 24 times 23. You get a 13800. Then you just divide those two numbers. You just do 1320 divided by 13800 to get a decimal. The decimal you're getting is 0.09565. Then if you want, you can convert it into percentage. You can convert to 9.565%. All right. This way is okay too. Or you can just end with a decimal. That's fine too. But ideally, when we're talking about probabilities, we want a fraction. So 22, actually, these two simplified with these two. So this actually in the end, we get 11 out of 130, 230 divided by 5. So, no, 40. Well, I couldn't do it. 46. So in the end, we can simplify this to be not 46. Not 46, because we divided by 2. Because 230 divided by 2. 115. 11 divided by 115. And we know this cannot be simplified because 11 is a prime number. All right. So ideally, for question 10, we get 11 out of 115. That'd be the best answer. But as I said, you can leave as decimal. Okay. All right. I need to erase this. Now let's see 11. Actually, allow me to make another video for 11. 11 to 14, I'm gonna make another video, all right?